In homework 3, question 3B, question 3, we're going to put demand of bonds, which has a negative, which it represents a negative relationship between the price of bonds and the quantity of bonds demanded, and then the supply of bonds, which represents a positive relationship between the price of bonds and the quantity of bonds supplied. Just to make sure that you understand which curve is which, the slope of the bond demand curve is negative 0.3, negative. And the intercept of bond supply is 601. Okay, so this is the intercept of bond supply, and this is the slope of bond demand. And that's just to make sure that you understand which curve is which, right? Okay, now at the equilibrium here, we want to know the price of the bond. Now, one way to do this is to use this website called Desmos.com. It's really slick. What you want to do maybe is set the axis both at 0, and then set these out at, say, 1,000. Maybe this one's 2,000. Okay. And then what we'll do is we'll just copy the equation. That's the supply curve. There's a supply curve. And then we got to get the demand curve. And with this, you might have to modify the big dash there. Oh, no, that's cool. It doesn't. Okay, so the cool thing about this is if you put your cursor right there at the where demand meets supply, the first number is the quantity. So the quantity of bonds here is 673.333 billion, and the price is 803. So the second one's the price, because the price is the vertical axis and the quantity is the horizontal axis. So the price is 803. So that's a really quick way to get that. 803. Okay. Now we have to go back to our spreadsheet here, and I'm going to go ahead and delete all this stuff out here. That's from the previous problem. The bond is a discount bond, and the discount bond means there's no payment, right? It's a zero coupon bond. The future value is $1,000. That's given to you right here. Okay. And we got one period. And then our price is 803, right? So we want to know the interest rate. Well, let's pull up our notes. Remember our PowerPoint notes? Let's go back to where we calculated the interest rate on a discount bond. Okay, so on a discount bond, if I know the interest rate and the face value, I can calculate the price. It's just you plug in the face value and then divide that by 1 plus the I. I can solve this if I don't know I, but I know the price. I can solve it for I over here. So another way to write this would be to is I equal to F minus the price divided by the price. That's another way to write it. Because P divided by P equals 1. Now I got a common denominator, P, so I got F minus P divided by P. So that's another way to write it. Okay? So that's one way to do it, or we could do the rate equation, right? We could do the rate equation, and I'll show you that too. So we could do it this way. Equal the face value minus the price divided by the price. And we get 24.53%. Looks like we want 3 decimal places though. Okay, another way to get that is to just use the rate equation. The number of periods is 1. The payment is 0. the price, remember, we got to pay the price to get the $1,000 in a year, is 803, and the future value is 1,000. We get the same thing with decimal places. So you can use the rate equation, or you can use the notes, the formula from the notes. So we'll copy this into here. We got to close this out. We don't need the percent symbol because you got the word percent after the box. It looks like everything's good there. Now we need to know the quantity supplied. Well, what I can do is I can solve this like I did before. I must not have. Okay, I don't know what was going on there. Okay, so the price is 803, correct? And I can solve this for Q. And I just subtract the minus 601. Subtract that from both sides. And then I divide by the slope. And that equals the quantity, right? So the quantity equals that. That's quantity supplied because I plugged it into the supply curve, right? Okay, now I'm going to do the same thing with the demand curve. Yeah, I'm going to do the same thing with the demand curve. Copy. Okay, but over here what I'm going to do is I'm going to add the 0.3Q to both sides. So I'm going to pull this down here. I'm going to add this to both sides because it's negative, right? And then I'm going to subtract 804 from both sides. And then I'm going to divide both sides of the equation by the slope, which is 0.3. And then I can plug this down into here, right? And I should get the same number. Oh, I got a space right there in front of the equal sign. Oh, that's a long dash instead of a subtraction symbol. Okay, let me see what we got going on here. So, oh, I see the problem. When I pulled this down, it increased the 803 to 804. So, that's the problem. It changed, Excel changed the price to 803, or 804 instead of 803. So that threw us off a little bit. Excel's kind of funny like that. There we go. So the quantity demand and the quantity supplied are both the same value. Because at this price of 804, quantity supplied is equal to quantity demanded. At a price of $600, the quantity supplied is way down here. The quantity demanded is way up here. At a price of 1,000, the quantity demanded is up here. The quantity supplied is out here. As the price comes down to the equilibrium, the quantity supplied and quantity demanded are both equal to the same. Okay, so let's hit enter here. And we could have got that from Desmos, right? Remember, the quantity supplied and the quantity demanded is 673.33, so we could have got that from Desmos. Okay. Okay, so since both of these are equal, there is no excess demand / supply. Okay, now let's go down here and graph it. Okay, again, we got to label the axis. axes. Price, quantity, supply, demand. The equilibrium, maybe I'll the equilibrium point. And the price. So 803 is the equilibrium price, and 673 billion bonds is the equilibrium quantity. That's supposed to be billion. Okay, that's how you'd graph that graph. Or label that graph. Okay, good. So let's move on. Suppose expected inflation decreases by 7.524 percentage points. Okay, what's going to happen? Okay, so I wrote out the Fisher effect, the Fisher equation, and when we're analyzing bond shifts, what we want to do is we want to hold the price constant. Okay, so we're moving from left to right. We're holding the price constant. So if we're holding the price constant to figure out what happens to demand, and remember, when price of bonds goes down, that means interest rates rise. Okay, interest rates rise. Man, that's really messed up. My mouse is kind of sticky. Okay, so if price goes up, interest rates go down. If price goes up, if price goes down, interest rates go up. But when we go from one demand curve to the next demand curve to analyze the effect of the shift, we're holding the price constant. So if we're holding the price constant, we're holding the interest rate constant. And this says expected inflation is going to decrease, right? So we expect expected inflation to decrease. Well, if this side is not changing, then this side can't change, which means the real cost of borrowing has to go up. Okay, so if this goes down by 2, that's got to go up by 2 in order to keep this constant, right? And that's why, so the real cost of borrowing is increasing, right? The real cost of borrowing is increasing. What's going to happen to the expected return on bonds? Okay, now in order to answer that, we have to go back to our notes, right? We have to fast forward to our notes, through our notes. Okay, so this is the return, this is the current yield, and this is the gain, right? So what's going to happen here is if expected inflation decreases, because these prices are what we already paid. Let's go to a different version of this. Let's go to a different version of it. We'll replace F with a future price. There we go. Okay, here we go. This is the one we want to talk about. Okay, suppose this is the future price, and we might sell it a period from now, which is before the face value. Okay, so if we sell it before we redeem it with Treasury or whoever issued it, then we're gonna get a future price, right? This is today's price. this is the price we paid today. So these three things are fixed. The coupon payment, we're going to get that in the future. We're going to get this in the future, right? But the thing is, that's fixed because we've already paid it. That's fixed and that's fixed because we already paid for this bond. If expected inflation decreases, then the value of that future payment is going to have more purchasing power. And that coupon is going to have more purchasing power. So this is going to increase, and that's going to increase. So our expected return is going to increase. So the expected inflation decreasing increases the real rate of interest on bonds. It increases the relative expected return on bonds, and both of those increase the demand for bonds. Now, both of these factors, the higher real rate of interest and the higher relative expected return, increase bond demand. And the reason why that is because the demander of bonds pays money, the price, to get loan payments, right? They're getting these payments, these coupon payments. So they're lending money out. So the demanders are lenders, and they're going to want to lend more when the real rate of interest is higher. So that's why bond demand increases for that reason. And then it also increases because of this, they expect more of a return on these bonds. So that's why the bond demand curve shifts from black to red. And let's go ahead and label this diagram. Change it to black. Let's see if I can move that over here to make it easier. Okay, so the price, the quantity, supply of bonds at time today, the demand for bonds today. Change this to red. Demand for bonds, not today, but in one period from today. And then let's draw in the equilibrium, the new equilibrium point. Okay, so the quantity is going to be under 800, right? 800. And the price is going to be probably at 950 or close to it. That's the new equilibrium. The old equilibrium, or the initial equilibrium at today, was right here. So both the price and the quantity increased. The price of bonds and the quantity increased. So this causes the price to go up. I'll just call it P star. And the interest rate to fall. Because remember, interest rates and prices are inversely related. It also increases results in quantity being increased, right? Okay, so that's how you would graph that diagram. So now we're going to calculate the equilibrium, the new equilibrium price, and the new equilibrium interest rate, and the new equilibrium quantity of bonds. So what I'm going to do is I'm going to copy this equation. I'm going to go ahead and close this out. I'm going to copy this into Desmos and just have Desmos do it for me. Okay, here's the new equilibrium out here, right? The new equilibrium price is the second number, 830.5. And the new equilibrium quantity is 765 billion. And we'll hit enter to see if we got it right. And we did. Okay. Now we got to figure out what the interest rate is. Remember, the price was $803. The price increased to $830.50. The interest rate was 24.533. The interest rate should fall because the price increased. Let's go over here. The new price is $830.50. And whether we use the formula from the notes or the rate, Excel's rate function, we get an interest rate of 20.409%. So interest rates, in fact, did fall. Whoop, I forgot to delete the percent symbol. Okay, so that's what happens on the demand side when expected inflation decreases. Okay. Now, what about the supply side? There's going to be a supply side effect, right, when inflation decreases. Again, the real cost of borrowing increases, right? The real cost of borrowing increases, and that goes back to the Fisher effect. Because now we're looking at the supply side, right? Remember, when we shift a supply curve, we hold the price constant. And we're holding price constant, then we're holding the nominal rate of interest constant, right? So go back to the Fisher effect. When you're doing a supply shift, you hold prices constant, so you're holding the nominal rate of interest constant. Expected inflation decreases. If this decreases by 2, then this has to increase by 2, right? In order for this equation to hold. So the real cost of borrowing increases. Now, how are suppliers of bonds? People that supply bonds are borrowers. If the real cost of borrowing increases, they're going to want to maybe issue less debt. They don't want to take on as much debt. So that's why the supply curve decreases. Which decreases the supply of bonds. Okay. So the supply curve decreases because the cost of borrowing is higher. Demanders, on the other hand, want to buy more bonds because of the interest rates. Real cost of borrowing is increasing. They're getting relatively higher payments here, but the cost of borrowing is increasing on the supplier, so they're not going to issue as many bonds. And then the new equilibrium is right there. Okay, so at the new equilibrium price, I'm going to copy this equation into Desmos, and the new equilibrium is right here, so it's going to be kind of above the original equilibrium. So the new equilibrium, here's the original equilibrium here, right? And then we shift it out to here. And so the new equilibrium is right there. So there's the original equilibrium. Here's the new equilibrium. The new equilibrium price is $8.55. So the new equilibrium price is $8.55. And we'll have Desmos calculate the quantity. And the quantity looks like 683.3333. 683.333. Let me double check to make sure that's correct. Okay, good. Now going back over to Excel, we had to type in the new price, $8.55, and interest rates fell substantially to 16.959%. Okay. So this is our new supply curve. This is our new demand curve. The quantities didn't change that much. The quantity of bonds in equilibrium didn't change that much, but the price went up substantially. Okay, so prior to the decrease in expected inflation, the interest rate was equal to what? Well, we have to go back to the original scenario up here. The interest rate was 24.533%. The interest rate equals blank percent after the decrease in expected inflation. So here's the first effect, and then here's the second effect. And so this is what happens to the price or the interest rate after the decrease in expected inflation. And that interest rate is 16.959. Okay. And we can hit enter to find out that we got the right answer. Okay, good. Now, remember, it was assumed that expected inflation decreases by 7.524%, right? So this effect here is what causes both demand and supply to go from the black curves to the red curves, right? What happened to the interest rate? How much did it decrease by? Well, prices increased from here to there. Interest rates decreased from there to there. So let's calculate the difference in interest rates. So 24.533 minus 16.959 gives us 7.574. Okay, so notice that the change in expected inflation is roughly equal to the change in the interest rate. So the Fisher effect is defined to be the change in interest rates divided by the change in expected inflation. That's just the slope, right? That's just the slope. Let's write that out again. So the Fisher effect is this relationship here, right? Okay, you can think of this as the intercept, right? And then we can think of 1 as the slope. And remember what the slope is. It's the change in the y, in this case, nominal rate of interest, over the change in expected inflation. And in this case, the slope is a +1, right? So the Fisher effect is defined to be the change in interest rates divided by the change in expected inflation. In our model up here, we have to take this change and divide it by that change. Okay, so the change the change in interest rates is 7.574. We're going to divide that by the change in the expected inflation rate, 7.524. Hit enter and we get something that's really close to 1. Let me go ahead and close this so I can enter the answer. Okay. Now down below, this figure down below suggests what? We have this scatter plot from FRED, Federal Reserve Economic Database, of expected inflation and nominal interest rates. And when we have Excel insert a trend line, the slope of this trend line is 1.1. So we can put in 1.1. Now, it gives us an estimate of the intercept, which is 1.7. So if this is a valid regression, which is not the focus of this course, you could do this in econometrics if you wanted to, but you can interpret this as the real rate of interest, because remember, the nominal rate of interest is the expected inflation rate plus the real rate of interest, and this is really close to 1. So you could think of this as the real rate of interest, 1.7. That's how you'd interpret that. Then we hit enter, and we get everything correct. And so we've used theory, bond demand and bond supply, to derive the Fisher effect.